Good morning. My name's Eddie Paddock. I work in the virtual reality lab here at Johnson Space Center. The virtual reality lab is part of engineering's simulation and graphics branch. Our charter is to build virtual reality tools and equipment to train astronauts in space environments. Specifically, it's mostly for EVA spacewalks on space station. And to do that, we have to build up the graphics systems. This is a picture of Doug, which is our kind of flagship tool. That's an actual rendering image of the space station, orbiting Earth. We also build up wearable technologies, HMDs, head-mounted displays, and tracking systems, electromagnetic, and with some of the new infrared tracking systems. So I'm going to talk about non-tethered systems for virtual reality. By non-tethered, I basically mean with no cable drag. So I'm talking about high-fidelity graphics systems that we use that are integrated with our simulations. That are drawing maybe 4 to 5 million polygons. So not something like Google Cardboard or VR Gear, more of a high-fidelity systems. So until recently, you had to have high-powered graphics cards and platforms to do that type of virtual reality immersion. So high-end graphics cards, head-mounted displays that were real expensive, expensive tracking systems, and again, cable drags for HMDs. But with the emergence of COT systems these days, like Oculus and HTC Vive, you have 4 gigahertz processors. You also have high-end graphics cards with laptop footprints where we can get that performance. And then also game engines like Unity and Unreal that we've been working with. So it's now possible to build up kind of a backpack option that's anywhere from 3 to 12 pounds, where you could be mobile with your VR system. So this is a picture of some of the systems we're working with, HTC Vive, and actually I just got my official one in today, where they've released a couple development versions. So the top picture there is another group in our division that's doing some work with HTC Vive, and that's an IVA in the space station. We can walk around the space station. The HTC Vive comes with a lighthouse tracking system, which is infrared, and it triangulates to some active sensors that are in the hand controllers in the headset. So it allows you kind of a primitive avatar to walk around, so you could immerse yourself into the space station. The bottom is an Oculus application we built to do some training with HERA, the Human Exploration Research Analog, for Itokawa asteroid mission, where you have 2 astronauts in EVA and then a couple more in the vehicle. And that's actually using an external tracking system with reflectors called OptiTrack. So that's another pretty low-cost tracking system for avatar tracking. So when I talk about these mobile image generators, this is the idea where you would just have a connection from your HDMI to and USB to your laptop. So there hasn't been a technology developed with HDMI to do it, wireless. You have it at your home for your TVs and stuff, but that's all has a pretty good lag in it. So you can't really sync that up to the head movements and the tracking systems, or it'll make you sick and it'll be jittery. So the option you have is hook up HDMI cable to your laptop. And again, you're even limited with that with length. You get over 25 feet and you have to have a Ballon extender, which actually causes lag, which again doesn't integrate well with a tracking system. The other picture in the lower right is another company I saw at ITSEC. Motion Reality, which has a similar design for military applications. And then the backpack there is Oris is coming up with a nice backpack where you just strap it laptop on and plug in. And there's other companies. Again, the technology that allows you to draw high fidelity graphics really is like the i7 and the 980 graphics card that NVIDIA has. And they've just released basically a desktop version that has a laptop footprint. So that's what we're looking at using. This just gives you an idea of where at NASA where we need a mobile kind of untethered VR approach. We're working on this now with Argos, which is our active gravity offload system. So if you look in the lower right, there's an astronaut on the crane. It's basically a robotic crane that can emulate anywhere from 0G to 1/6 gravity, or however you want to simulate it. So an astronaut would be EVA there in the virtual environment on the handrail. Another astronaut could be training in the virtual reality lab with the hand controller for SAFER, that simplified aid for EVA rescue. So that's basically the safety jetpack in case they become untethered to fly back. And a third astronaut could be inside the station in the cupola, looking out at the activity and even assisting with a laser rangefinder, seeing the astronaut's closing rate as he flies back. Because astronauts, they have to be certified actually in our lab for SAFER before they do a spacewalk as a safety precaution. So this gives them an integrated, distributed training environment where this mobile untethered version become real handy, especially for Argos, the astronaut in Argos. Some other ways of mixing in hybrid or mixed reality that we're looking at is mixing in real-world objects into your virtual scene, like handrails or tools, and where you could calibrate that with the tracking system. So you reach out and you actually grab a physical object that's matched to that's calibrated to the geometry of the rendered graphics. And one step further is to use something like green screen or chroma key technology to basically overlay or to mix in real video into your virtual reality, so you could use that to track and have something like you could do planetary surface training and have a Mars background. There'd be real rocks or real tools that you filter out of the video and overlay into the virtual reality. That's just a picture I grabbed from the net that gives you an example of that. That's about all I had, so thank you.